Now that we have a decent amount of differentiation rules in our toolbox, we're going to talk about something called higher order derivatives. Higher order derivatives, it might be exactly what it sounds like. The derivative that we've been finding is called the first derivative. We haven't had a reason to distinguish this between other derivatives because it's the only derivative that we've been finding. We've just differentiated a function once. That is called the first derivative. In this section, we're going to repeat that process and get what is called the second derivative, the third derivative, the fourth derivative, the 100th derivative, etc. We will spend some time talking about how to notate higher order derivatives, then practice finding some, and look at a physics application to acceleration. Since the derivative of a function is itself another function, meaning that it has variables in it and it has outputs that give us the slope of the original function, then if the derivative is differentiable, meaning it has a derivative itself, then we can find the derivative function of the derivative function. That's really confusing, so in other words, we call this the second derivative function. And we can actually keep on going and find the third derivative function, the fourth, the fifth, actually as many derivatives as we'd like. Here is how we notate higher order derivatives. This table is sort of divided in half here, depending on how your function looks to begin with. Whether it's given as f of x or y prime, then we'll notate it slightly differently, but the notations are really very much related. So if we start with f of x and we want to find the first derivative, well, we know how that's notated. This d dx here means take the derivative of f of x. Take the derivative of what's inside of these brackets. We notate that as f prime of x. We've seen this a lot. We've been working with this notation a lot. To notate the second derivative, we just add another prime or another apostrophe here. We would call this f double prime, not f prime prime, but f double prime, or the second derivative. It is the derivative of the first derivative. So that's how we find it. We differentiate f prime of x to get f double prime of x. If we want to find the third derivative, we will find the derivative of the second derivative. We will stick another prime here, f prime 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 of x, or f triple prime of x, or third derivative. Moving on, if we want to find the fourth derivative, then we differentiate the third derivative, but it's getting really crowded up here with all of our primes. It's hard to count them. So once we get past the third derivative, we put the number of the derivative in parentheses here, sort of in the exponent or superscript position. Okay, so the reason these parentheses are here is because if we just raise to the fourth like this, that is to the fourth power. But we want to make sure it's known that this is the fourth derivative. So if we have an exponent sort of in parentheses like this, this refers to that number derivative or that ordered derivative. In general, beyond the fourth derivative, if we want to find the nth derivative, then we differentiate the derivative before the n minus first derivative, and that gives us the nth derivative notated like this, again with parentheses, as long as your n is greater than 3. Now, if your function is given to you in terms of y equals, then we'd follow the same kind of procedure with all of the primes. We would call our first derivative, as we've seen, y prime. Our second derivative would be y double prime, and that would just be the derivative of the first. Our third derivative would be y triple prime, which would be the derivative of the second. And then beyond that, we put the number of the derivative or the order of the derivative in parentheses in the exponent position or the superscript. And this last column here, we won't use that much, but it's important for you to be familiar with all of the ways that you can notate derivatives. So if we, instead of y prime, if we're using dy dx to talk about the derivative of y, then when we differentiate dy dx, what we are doing is sort of doing derivative of, like that, d dx of dy dx. And the way that we notate the second derivative in this way is we put a 2 in the superscript of the d, meaning take the derivative twice of y. And then we put a 2 in the superscript with the x down here, which means that we're differentiating with respect to x twice. We follow this pattern, and if you find the derivative of that, meaning you get the third derivative of y, then this becomes a 3 with the d in the top and a 3 with the x in the bottom, and so on. So the fourth derivative, again, the 4 with the d up top and the 4 with the x down in the bottom, and in general, just d with an n in the subscript up here and an n in the subscript down here.